So reminder to you guys, when is your test? Friday. Friday is your big test. Friday is your test. Guys, today, tomorrow, what's today? Tuesday, Wednesday, Thursday are all kind of review-ish type days. Okay? To me, today, like what we're looking at, a lot of times is a big aha moment for a lot of students. You know we have 4 methods. You know some work sometimes, some not so other times, whatever. I think today is one of those days where you're like, oh, that's why we have different methods, okay? Because we're going to look at the same problem, all 4 methods. We're going to look at, can I use this method? Can I not use this method? Like, how do I tell which one's which? Okay, because your test on Friday, it's going to be broken up into different sections. You're going to have a section for each method, right, where you must read the directions and use the method I asked for. Otherwise, it's all wrong. And then you're going to have the last page of your test where you'll have 6 problems. I'll tell you to use any method you want, but you have to use each method at least once. So 4 methods, 6 problems. So if quadratic formula is your favorite, how many could you use quadratic formula on? 3. You could use it on 3. But the hardest part about that whole last page of the test is how do you know which methods work on which problems? That's what we're going to focus a lot of time on today, is helping you figure out when I can use which method. Okay? Noah? I can use quadratic formula on any quadratic equation. Anyone. If there's an x squared in it, I can use quadratic formula. What did we learn that I can calculate pretty quickly that tells me whether or not it's factorable? The discriminant, the b squared minus 4ac. Remember we learned about that? What does your discriminant have to be so that it's factorable? A 0 or a positive perfect squared, right? 0 is not really positive or negative. All right, so let's take a look. That's honestly the first thing I'm going to look for is I'm going to find my discriminant, because if you're not great at factoring, like if that's not like your strong suit, like where you're at, some of it might be for you. But if it's not, do you want to waste a whole lot of test time trying to get it to factor if it doesn't? Stop staring at her. She's weird, I've noticed.
She's eating an apple with a spoon.
A plastic spoon to boot.
Oh, plastic.
All right. So guys, we need to set this equal to 0 first. So 2x squared minus 72 equals 0. I'm going to find my discriminant first, so I'm going to find it right there in the center, just because where else will I use that discriminant then? In the quadratic formula. So if I kind of make a note of it where it's at, then I can kind of reuse it later. So if I find b squared minus 4ac, that's my discriminant. I don't have a b, so it's 0. So 0 squared minus 4, what's my a?
2.
What's my c? Go ahead, somebody calculate that for me. Is 576, is that a perfect square?
Yes. Go to my locker.
No. All right. So did you, yes or no, is that a perfect square? Yes. So since that's a perfect square, that means we can factor this. Okay? So we had 2x squared minus 72 equals 0. Okay, so we know it's factorable. What do I do first to factor it? It could be, who knows, routine, safety thing. I don't see any vehicles that would make me think it's the drug dogs. They could be just checking to see if people know what to do in a situation. That's why I just went over and pulled my door shut, because now my door is locked. Guys, no. How do you factor that? What? Good. I can factor out a 2, right? I can divide them all by 2. So we get x squared minus 36. Right, taking out my GCF of 2. How do you factor, Cole, that's x squared minus 36? Thank you. That's the difference of squares. X plus 6, x minus 6. Guys, turn around. Should I worry about you?
No, not me, but it's going to be funny when I find out what it is.
So what does x equal? Thank you. Remember, we set these equal to 0 and solve, right? Does this give me an answer? No, there's no x here. So x equals negative 6, and here x would equal 6. Guys, I need you to focus, please. We have a test on Friday. If you fail this test on Friday, you can pretty much kiss the second quarter goodbye. This test is huge. Guys, I need you to focus, okay? All right. How about square root method? Can I use the square root method on this problem? The fact that it's perfect square has nothing to do with square root method. What has to be missing? The b. Is it missing the b? Yes, that means I can use this method. So 2x squared minus 15 equals 57. So square root method equal to 0 or no? No. I want to get the squared term by itself. Good. Add 15. 2x squared equals, good, 72. Then what? Divided by 2? No. So x squared equals 36. You would not want to take a multiple choice test from me. No, you wouldn't. When I make multiple choice tests, I go through and do the problems with all the common mistakes students always make. So you'll do those mistakes on the test and be like, oh, there's my answer. I must have got it right. I give you a false sense of security, and then it's wrong. Josh, that's so smart of you. It's good advice. All right, so x squared equals 36, then what? Square root. What's square root of 36? Plus or minus 6. I got the same answer. Should you? I solved the same problem, right? I should get the same answer. I just used 2 different methods. All right, between those 2 methods, which one do you prefer? Square root method? On a problem like that, I would use the square root method because it's faster. A lot faster. All right, what about completing the square? Can I use that method? What must you have? You have to have a b. I don't have one. Must have b. The problem, it would be 0, but the problem is, in this method, I have to do b over 2 squared and add it to both sides. What's 0 divided by 2? Squared. Am I changing anything? So can I actually do this? No, I can't. So what do you know about the square root method and completing the square? Can I ever do them both? No. On one problem, I can either do one or the other. It either has a b or doesn't have a b, right? It kind of depends on the problem. Quadratic formula? Yeah, I can always do the quadratic formula. Set equal to 0 or no? Yes. So I have it set equal to 0 already, right? 2x squared minus 72 equals 0. We did that right here. All right, so x equals negative b. What's negative? 0. Plus or minus the square root 576. Thank you. We already found that, right? If you don't remember we already found that, you could write it all out again, but I'm lazy. I already found it. I'm just going to write 576. All over 2a 2 times 2. So 0 plus or minus square root of 576? 24. All over 4. Can I divide all three numbers by something? By 4. Yeah, I can divide them all by 4. What's 0 divided by 4? 24 divided by 4? 4 divided by 4? 1. I don't really need that. So what is 0 plus 6? What's 0 minus 6? 5, 6, and negative 6. He did. I chose to ignore him. Yes, no. If you have like 2 methods shown on a problem, as long as you at least did it in the method I asked you, that's fine. So in other words, could you check your work by using the quadratic formula? Yeah, if that's your go-to, you're comfortable with quadratic formula, you can check your work with that. But I better see the method that I asked for. Okay. Wrong. Hopefully, yeah, it's a red flag to you that I did something wrong. Should go back and fix that. Then you better pay attention today, tomorrow, and Thursday. The test, some people will probably take the whole time. Yeah. All right, next problem. X squared minus 44x minus 45. Can I factor this? How do I check? The discriminant. So let's find our discriminant. Remember, that's b squared minus 4ac. So b squared, we'd negative 4 squared minus 4 times 1 times negative 45. Calculate that for me, guys. 196. That's my discriminant. Is 196 a perfect square? Yes, it is. So since this is a perfect square, I know then that I can factor this. Okay? Factoring, set equal to 0 or no? Yeah. It's already set equal to 0 for me, so that's good. Is there a GCF here? No. So I'm going to set up my parentheses. X squared, just 1 and 1, so 1x and 1x. What are your signs? Last one's negative. Plus, minus? 45. 5 and 9, 1 and 45, 3 and 15? It'd be 5 and 9, yeah. Hopefully, most of you, I hope, are at the point where you can look at them like, oh yeah, 9 and 5, yeah, that works. Okay, if not, make your list, see if you can figure out which one works. Which one has to be negative? The 9. Okay, so then what does x equal? Negative 5 and 9. Right, you're setting each one equal to 0 and solving. Hopefully we're at the point where we can not show that work there. Is there anybody questioning how I got my answers from the factored form? If you're not sure, make sure you ask. Because remember, once we get it factored, what you're doing is setting each factor equal to 0. And then we solve. So subtract 5. That's where I got negative 5. Add 9. That's where 9 came from. All right. Model one's so bad, right?
So you're supposed to be getting the 4 in the middle, right?
Right. Yep. All right, square root method? No, I can't do it. It has to be missing the bx, so that one doesn't work. Complete the square? Yeah, if I can't do that one, I can do this one, right? It's either one or the other. Equal to 0 or move C? Move C. So x squared minus 4x equals positive 45. All right, move my C to the other side. Divide by A. Doesn't really do anything. B value is 4 divided by 2. 2 squared, which is 4. B over 2 squared. How does this factor? X minus what? 2, good. Equals 49. Then what? Square root. Very good. Plus or minus 7. So x equals, I have to add the 2. Plus or minus 7. 2 plus 7. 2 minus 7. And then we have the quadratic formula. Can I always use that? Yeah. So x equals negative b, 4, good, plus or minus the square root of 196. I already did the math. I'm going to be lazy. I already did it. All over 2 times a. Square root of 196, 14. Can I divide all 3 numbers? Yep, divide them all by 2. 4 divided by 2. 14 divided by 2. 2 divided by 2. 1. Okay. What's 2 plus 7? 2 minus 7. What's your preferred method on that one? Some of you will tell me quadratic formula every time. My preferred method on that one is factoring. It's an easy one to factor. There wasn't a lot of guessing and checking going on there, right? Okay. 2x squared plus 13x plus 21 equals 0. Can I factor that? Just by looking at it, do I know if it factors? I have no idea. All right, so how do I find out if it factors? Discriminant. Yeah, find your b squared minus 4ac. b squared, 13 squared, minus 4a. C. Help me out. What do we get? 1. Is that a perfect square? Yeah. So yes, it can be factored. Okay, so let's factor it. Is there a GCF? Nope. All right, set up your parentheses. What are your signs? Both plus. Options for A? 2 and 1, so 2x, 1x. Options for C? 1 and 21 or 7 and 3 or 3 and 7. You want to go 1 and 21 or do you want to go 3 and 7? You want to go 3 and 7 or 7 and 3? What did you say? 7 and 3? Let's double check that. Inside gives me 7, outside. Does that make 13? Yeah, so we know we factored it good. So then x equals, set it equal to 0 and solve. Negative 7 over 2 and negative 3. Again, all you're doing is setting those equal to 0. And x plus 3 equals 0. And solving. I'm just not showing that work anymore. You should be able to do those in your head by now. Square root method? Why not? It has a b. Good. Completing the square? Yes. This is going to be a fun one. Yay! So what's your first step? Move C. So the 21, we need to move to the other side. It's negative 21. Then what? Divide by 2. Yeah, there's that darn a value right there. So x squared plus 13 over 2x equals negative 21 over 2. Oh, this one just gets better and better. Yep. Which makes it what? Yeah. Good. Your b value is 13 over 2, and then we have to divide that by 2, which is 13 over 4, and then we have to square that. So it gives you 169 over 16. thankful for a calculator right now, right? All right, how does this factor? X plus 13 over 4. Again, that little side note that we make, isn't that great? It's right there. I don't even have to think about it. Negative 21 over 2 plus 169 over 16. Do you concur? Over 2? 1 over 16? Okay. And I heard your answer, I'm like, I don't think that's right. All right, then what? Square root? Top? Bottom? Bless you. So on this side, we get x plus 13 fourths equals square root of 1, square root of 16. Don't forget your plus minus. Where did I lose you? Okay. There's no radical, there's no I, so I have to actually tell me the answers. Negative 13 fourths plus 1 fourth is what? Negative 13 fourths plus 1 fourth, yep, negative 3. Negative 13 fourths minus 1 fourth, negative 7 over 2. Would that be anybody's preferred method? Yeah, no, not a chance. No, I was like focused on something somebody else said, so I wasn't like doing the math in my head at that moment. You have to use each method at least once. So thinking about that back page of the test, which method should you probably do first? All right, quadratic formula should be the last thing you use because that works for everything and we know it works for everything. Which one is probably the easiest to recognize? The square root method, because it has to be missing what? B. Chances are there's probably only 1, maybe 2 that are missing the B. Okay? There's 6 problems. You have to use each method once. So the first thing I would do is I would find the one that's missing the B, use my square root method, get that one done out of the way. Okay? What's the next thing I would probably look for? Factoring. How do I tell if it factors? Good. Find that discriminant, and if it's 0 or a positive perfect square, I know it'll factor. Okay, so find the bx term, the one that's missing that first, do your square root method, find which one factors. And then really everything else, I could use either completing the square or quadratic formula. Which type of problem might you choose to use completing the square on? If it's missing what would probably make it the easiest? A. Because when I divide by A, sometimes I get some crazy fractions like that one. So if I have some problems left over and I'm like, that one doesn't have an A value, maybe I'll go ahead and use completing the square on that one. Try to avoid crazy fractions. And then once I've done 3 problems, the rest, if that's your go-to, I would go ahead and use the quadratic formula on the rest of them. Okay? Could you factor probably more than one? Yeah, probably. Do you have to? No. You have to at least one of them, though. All right, let's do quadratic formula on this one quick. So x equals negative b, yes, plus or minus square root of 1, we already did the math on that, over 2 times, what's my a? I got you. So negative 13 plus or minus square root of 1 is 1 all over 4. Can I divide all three numbers? Nope, not a chance. All right. So what's negative 13 plus 1 divided by 4? Negative 3. Negative 13 minus 1 is negative 14 over 4. Doesn't divide nice, but it would give me negative 7 over 2. So out of these methods, which is probably the easiest? Quadratic formula is probably the easiest. Factoring a lot of times is my go-to, but even on this one I might not, just because it's a kind of a guess and check one. Yeah, completing the square on this one's ugly. Can you still do it? Yeah, but it's not a pretty one.